Assalamu alaikum. My name is Irfan and I am a student of Mechatronics 5B, and today I am here to present a video presentation on the topic of line following robot, the project that we have made for our MES course. So I am about to start the screen. So here it is, our lab project report. And okay, so we basically were four members of the group, and we just divide um, the whole project into four parts, and I was the member of the technical team. I have done a lot of technical words like PCB hedging and testing and also soldering, and I have done the most of the hardware part. So let's begin. So here is the things that we have put in our reports. In our report is that first of all, we just describe the proposal, what is our project is about, and then we just define that how this project will gonna work for us. And then we also include the estimated budget, because as an engineer, if we work for any company or any um, project, so the first thing that we have to keep in our mind is the maximum budget we can use to make this project. So we also have shared the details of the amount that used for this project. So, okay, so here are the price list, and our total estimated budget was about 8,000 to 9,000 rupees. So, we just bought the car, chassis, soldering iron, soldering wires, sensors, and a lot of other things. So, it cost us around 8,000 to 9,000 Pakistani rupees. Okay, so it's the introduction that um, robots are basically the complete automatic machine, as we all know, that it starts working when sense something. So our project was to make a robot which follows the line. It doesn't matter if the line is straight or curved or in a linear path. So our main task was to achieve our goal, to let our robot to follow the line. So for this purpose, we used different sensors, encoders, Wi-Fi modules, and Bluetooth, etc. So we also share the details of all the components that we have used in this project. First of all, there will be ultrasonic sensor. As we all are aware that ultrasonic sensors used for to detect the distance, and also help the and also give the signal to robot or the our line following robot to change the direction, or how many distance will be kept after this. So basically, ultrasonic sensor is used to measure the distance, and ultrasonic sensor send a high pulse signal and then a low pulse signal in a continuous manner. So whenever it detect any obstacle within the given range, it sends a signal to the line following robot, and allow us to change its paths. So if we talk about the pin configuration of ultrasonic sensor, there are four pins. One is VCC, second one is trigger, third one is eco, and the fourth one is ground pin, which is connected to the ground of the system. So operating voltage at which the ultrasonic sensor operates is around 5 volts, and the theoretical measuring distance is about 2 centimeter to 450 centimeter. But if we talk about the practical measuring distance, because we didn't use a very expensive ultrasonic sensor, so our practical measuring distance was 2 centimeter to 80 centimeter, and the accuracy was 3 mm, and the measuring angle covered, and also the current and the frequency that is also measured here. So as we all know that the ultrasonic sensor is a 4-pin module, and we also mentioned the pins. So ultrasonic sensor works with the simple high school for formula, which is that distance is equal to speed into time. So ultrasonic sensor has a transmitter and a receiver. So transmitter send the signal or array which detect the obstacle, and it comes back to the receiver. So the time that it has been taken from this for this one complete cycle is used to measure the distance of the obstacle place around the line following robot. So the main thing that we can say that the heart of the project is that Arduino. LFR can be uh, can be made by using different we can say PCBs or Arduino or many other components, but we prefer to use Arduino because it was our requirement for this project. So as we all aware about the Arduino, how does it work? So I'm not going in detail to explain the working of Arduino. The main thing that we have to know for Arduino is that it has some power pins like 3.3 volt, 5 volt voltage input, and also the ground pins, and we also have a reset button on it, and there are six analog pin in Arduino Uno, 0 to 5, and also 12 14 digital pins 0 to 13. And we also can use external interrupts, interrupt to 2 or 3 to trigger and interrupt. So, as we all aware about the working of our Arduino Uno, so the other thing that we use in this project are our IR sensors. Okay, so what does IR sensor mean? IR sensor basically is used to stand for infrared sensor, and it is also used to we can say. Okay, so IR sensor can be used to measure the obstacle, or is also can use for the distance measurement. So if we talk about the IR sensor, we use three IR sensor in this project. One is at right side, which help the uh, our robot to follow to go to the right direction if it will found any obstacle near it, and we can adjust the range of the robot through which if it will detect the specific obstacle, it will move either left or right, or if there's no obstacle, it will tend to go straight forward line. So that's why we use three IR sensor. One is for right turn, and the other one is for left turn, and the center one will keep our line follower robot to follow the straight path. Okay, so if we can see the pins, we can say, or the range of IR sensor, it's only about 20 centimeter. We also can change the range according to our requirement, but the max range is just 20 centimeter. So there are also input pins are 5 and 3.3 volts. Okay, so this is the mounting holes. Basically, there are two LEDs placed in this sensor module. IR sensor, one is the emitter and the second one is the receiver. So the emitter will emit the rays. It will detect the obstacle, and after clash with the obstacle it will come back to the receiver, and the time will be measured, and the time is used to measure the uh, distance of the obstacles placed in front of we can say in front of our robot. So the other thing that we use is the motor driver. As we all know that the motor driver is a high power driver module, which is used for driving DC and stepper motors. So as we also use two motors in our robot, so basically motor driver is used to boost up that motors. Okay, so there is the pin configuration of the motor driver that we have used. So we have mentioned the detail of these pins. Okay, so the other thing is that how would driver work, or the we can say the maximum limitations of the driver. So the maximum peak motor current will be around 1.2 ampere, or the continuous motor current will be around 600 milliampere, or we can say that if we talk about the voltages of the motor driver, it will be around 4.5 volt to 7 volts, at which the motor driver will work. So we also can control the speed and the direction of motor driver, and it also can be used to run two DC motors with the same IC. So okay, so here we use the TT gear motor in our in our project. The TT gear motor can be found in four different gear ratios and a single and dual output shafts. So here we also mention the we can say the limitations of this TT gear motor. After that, as we were asked to use some specific components which were necessary in our project, like we use current sensors, voltage sensor, and also we use encoders, interrupts, and also we used modules of Bluetooth module and also SD card. So these were the basic components that everyone had to use in this project. So here the current sensor, and we are very much aware of the working of this, and also the voltage sensor, as I have explained that we also use the voltage sensor. Potentiometer is the very basic component which is used to which is used to control the speed of current, which help our circuit to which help our circuit to work in a much better way without without harming our components. So okay, so the uh, we also explain in the support that how we uh, design our product, how we made our PCB, and that was such a we can say that a challenging task that we have made, because it was quite difficult to make two PCBs and then align them, and then um, to fix component on it. So that was quite a difficult task, and we also define everything about this project, that how we made it, and which type of challenges that we had. So now if we talk about the chapter 5, it's about programming and sensor integration. We also made the program, uh, because if our program will be good enough, it will help our line follower to go in a very smooth direction. So here the integration of ultrasonic sensor, optical encoder, current sensor, and also very okay. So if we talk about the block diagram, okay, so if we have to explain that what our purpose will be, and which type of products will be used, and how many of them how many of the components will be used in the output, and how many of them will be used as a input. So in for this process, uh, block diagram is the very crucial part. So if we look here, that we just made the block diagram of Arduino, and uh, from the on the left side we attached all the we can say all the input devices, and on the left side we attach all the output devices. So as we attach the battery, which will give voltage to the Arduino, and we also made the voltage regulator that we use is that. which will convert 12 volt to 9 volt. That will be enough for Arduino Uno to work on. And then we also use the voltage sensor encoder, 3 IR sensor, interrupt Bluetooth module as an input. And then we use motor driver, ultrasonic sensor. Motor driver is used to drive the motor either on the right side or on the left side. So we can say that the we use 0 to 6 Arduino pins, 0 to 6 analog pins, and also we use some digital pins. Some of the sensors that work on Arduino that work on digital pin, and some cannot. So that's why we use analog pins for them. So if we look, voltage and current sensors use analog pins, and also relay and the motor driver use some analog pin. The other components was attached with the digital pins. So as we also have attached the bill in the start, but here are the final bill of the material components, the final amount that we use in this project. So here it is. We were expecting around 7,000 to 8,000 cost, but it was quite expensive. Uh, it was around 850 rupees up to our expectations, because uh, we first made our PCB and it didn't work better. So there was some alignment issues, some hatching issues. So we have to buy a new PCB and then hatch it again, and then solder the components again. So that's why it cost us a bit more, around 7 to 800 rupees. So we also remember the task and the group members have done. So the last chapter is the project management, and how we manage this project, the PCB designing, the circuit designing, and the simulations, etc. So we just there are three procedure phases of this whole project. First, circuit design and simulation of on Proteus to check either if it work in a proper way or not, and then the simulation and proceeding of the circuit logic on breadboard, or we use PCB for this, and then the PCB designing and finalizing procedures. So here we attach all the list of the components that we have used, especially the sensors, which help us to understand that how much voltage or the current can it measure, and under what circumstances it can be work in a much better way. So here it is, all the uh, modules, components that we have used in our report. So overall, if we talk about the conclusion of this project, we have to learn a lot, because it was such a challenging task to follow, to let our robot to follow the line by using PCB, because PCB is a very sensitive, we can say, to make. So overall, if we talk about, it was a very learning and a fun project. I managed to learn about Arduino Uno and the sensor better than I did in last semester. So I am very hopeful that this knowledge will surely help me in the future, in order to manage any project, or maybe it will be very helpful for us in an interview. So I am looking forward to work on it in a much better way, and this will be very helpful for me to understand this.